So our question says here that consider the following equation: y triple prime minus 4y prime equals to 24e raised to the power 2t. So this is a differential equation, and we've been asked to first write the corresponding homogeneous equation and solve it. So our homogeneous equation is simply a differential equation equated to 0. So we're simply going to have y triple prime minus 4y prime equals to 24e raised to the power 2t. So we are going to call this our equation star, right? Now our homogeneous equation is y triple prime minus 4y prime equals to 0. We're going to call this our equation 1. So this is our homogeneous equation. So this is the solution to the first part of the equation. Now it says that solve it. Now in order to solve any simultaneous equation, you have to assume that it has a general solution to be e raised to the power. It can be anything, can be rt, right? So the reason I'm using r, or it can be even at or anything at all, right? Now this is the solution. This is a general solution to all differential equations. So you have to know this rule, right? Now with this, we are going to look for our first derivative, look for a second derivative, substitute in our equation 2. We can call this equation star, equation double star. Substitute it in our equation double star. That will be the solution for a. So for equation a, we are going to first of all look for our first derivative, right, of our general solution. So we'll look for this. So we'll look for this first derivative here. So this will be r e raised to the power rt. We'll look for the second derivative. We'll look for the second derivative. We'll look for the second derivative here. This will be r squared e raised to the power rt. We'll look for the third derivative, which will be r cubed e raised to the power rt. This is our third equation. So this, we notice that this is the third derivative, this is the first derivative. So we substitute equation 1 and equation 3 in our equation double star. So equation 1 and equation 3 in our double star, we're going to have r cubed minus e raised to the power rt minus 4. Equation 1 is r e raised to the power rt, now equal to 0. So what do we notice? So to better represent this is r cubed multiplied by this is multiplied. I don't know why it's happening there. So this is represented as e raised to the power rt. Good. So we notice here that r e raised to the power rt is constant, right? This can be any value. It can be a, right? This r can be a or anything. So if we factor out r, let's say we factor r e raised to the power rt, here we're going to be left with r squared minus 4 here equal to 0. Now this simply means that r e raised to the power rt is 0, or r squared minus 4 is equals to 0. So from here, this simply means r is 0, or e raised to the power rt is 0. This is not possible. This is not possible. So we are going to ignore this because it's not possible, and only consider this as our first solution. So we're done with this, right? We're here. Now, in order to get the values of the other two values of r, because this is our third degree differential equation, so it has like 3 solutions. So in this case, this implies that our r squared should be equal to 4, which implies r should be equal to plus or minus 2. So what do we notice? That there are 2 solutions, right, for our r. So meaning that our first solution r1 is 0, our second solution r2 is 2, and our third solution r3 is minus 2. So these are the different roots of our homogeneous equation. So the actual solutions from these different roots will simply be y general for our homogeneous equation is c1 e raised to the power r1t plus c2 e raised to the power r2t plus c3 e raised to the power r3t. Now we're going to end here because we have three roots and we can represent them in three terms. So if we had like 4, we're going to add plus c for e raised to the power r4t. But in this case we just end here, and we know that for r1 is 0, so this will simply be c1 plus our r2 is c2 e raised to the power 2t now, and plus our c3 e raised to the power minus 2t. So that's our solution for question A, and this solution is also the complementary solution, which we're going to see later in the video. But that's the solution for question A. So let's solve question B. Now question B says that find the full solution of the given inhomogeneous equation. Now notice that the question states given inhomogeneous equation, so this is actually our inhomogeneous equation. This makes it inhomogeneous. When it's equal to 0, it becomes homogeneous. When it's equal to a term on the right hand side, it becomes inhomogeneous. Now to solve this, right, to solve any inhomogeneous equation, there are two things we need to consider. First, the complementary solution and the particular solution. So the right hand side is going to help us to know the particular solution, right? In this case, if we look at our right hand side, we have an exponential function. So our particular solution will be of the form a e raised to the power 2t. This is going to be our particular solution. Now there's something I'm going to identify here. If you notice, right, this term here is similar to our particular solution, so meaning that when our particular solution is part of our complementary solution, that particular solution is not a solution to our inhomogeneous equation. Now you're going to understand why I'm stating this, but I'm not going to assume anything. So I'll solve this, and at the end you see why I'm coming up with these two assumptions. So just take note of that. And what we need to do is we look for our first derivative, second derivative, third derivative. So we're going to look for our first derivative here for this particular solution. We're going to have 2a e raised to the power 2t. Again, I already showed how to solve this in our previous videos, so if you're not understanding what I did here, simply check out those videos. Essentially what I did is differentiating our power and multiplying it by our original function. So our second derivative here will simply be 4a e raised to the power 2t, and our third derivative will simply be 8a e raised to the power 2t. This is our equation 1, this is our equation 2, this is our equation 3. So we're going to insert equation 1 and equation 3 in our particular solution here in equation star. So what we mean is equation 1 and equation 3 in equation star. We're going to get, not in equation star, this is our equation star here, not this, not the particular solution. Anyways, good. So in our equation star, we're going to have y triple prime is 8a e raised to the power 2t minus 4 into 2a e raised to the power 2t equals to 24 e raised to the power 2t. We notice that this is 8a e raised to the power 2t minus 8a e raised to the power 2t equal to 24 e raised to the power 2t. So 0 should be equal to 24 e raised to the power 2t. Now this is not correct. This is not true. Now once this happens, you have to know that this particular solution is not the correct particular solution for our inhomogeneous equation. again, as I said earlier, since this particular solution is part of our complementary solution, it's not going to be the correct particular solution for our inhomogeneous equation. So what we need to do is we increase the degree of our particular solution. So to get our new particular solution, in an exam you don't need to go through these steps, but if you go through the steps and you come up with an answer like this, you just need to know where the problem is. So you simply go back to your particular solution and you change the degree of that particular solution. So if I was solving this in an exam, I will not have to do these steps. I'll just change my particular solution will simply be this. My particular solution will simply be ax e raised to the power 2t. So I'll not have to waste time doing this and computing this. But I wanted to show you guys what I was explaining earlier. Again, so what we need to do is we look for our first derivative, second derivative, and third derivative. Then we take the first derivative and third derivative and insert it in our inhomogeneous equation star, right? So that's what we need to do. So looking for our first derivative here will simply be, again, this is a product, right? We're going to use a product rule. So in this case, we're going to keep ax constant. We're going to differentiate e raised to the power 2t. We're going to have 2e raised to the power 2t. Now plus, we're going to keep a e raised to the power 2t. Okay, so remember that our variable, this is very important, our inhomogeneous equation is in terms of t, not x. So this is actually t. So it's very, very important to know that this is actually t. So this is t here, t, right? Our correct particular equation is y particular equals to at e raised to the power 2t, because our inhomogeneous equation is in terms of t. Now what we need to do is we look for our first derivative of our new particular solution, which here we're going to keep at constant. We differentiate e raised to the power 2t, which is 2e raised to the power 2t. Then plus we keep a e raised to the power 2t constant. We differentiate t, we're going to have 1. So this will be 2at e raised to the power 2t plus a e raised to the power 2t. So this is our first derivative, equation 1, right? Now we're going to look for our second derivative of our new particular solution. So we're looking for this derivative here. Now this is where the logic comes in. Notice something. I want to show you guys something. This, right, is exactly this, meaning that our 2 is obviously a constant, right? 2 is a constant. We can factor it out. We saw that when we differentiated at e raised to the power 2t from here, right? From here, right? When we differentiated at e raised to the power 2t, we had all of this, right? So there'll be no need for me to recalculate it here. So these are just tricks, right? So there's no need for me to recalculate it. What I just need to do is copy this here. So copying it here, I'm going to have 2at e raised to the power 2t plus a e raised to the power 2t plus, again, what we have here, we have to now differentiate, right? We have to now differentiate. So we are done differentiating these two. This is a 2 out here. Differentiating at e raised to the power 2t will give us all of this term. So please, if you do not understand that, you can simply go manually like this, differentiating every term. Now differentiating this, we are going to have 2a e raised to the power 2t, and again I've also shown this trick in our previous video, so you can always check that out. So this is our second derivative. We're going to simplify this. We simplify this second derivative. We're going to have 4at e raised to the power 2t plus 2a e raised to the power 2t, and this is 4 here. Again, we're going to look for the third derivative of our new particular solution. What do we notice here? Again, this is a constant, so this will be 4, and this again is the same. This is the same as this, and we saw that when we differentiated this, we got all of these. So we're simply going to take this and insert here. So this will be 2a t e raised to the power 2t plus a e raised to the power 2t. Okay, then plus 2a, then we have to differentiate this, which will be 4a e raised to the power 2t. So that's our third derivative. We simply need to simplify this. So this, to simplify that, we're going to have 8a t e raised to the power 2t plus 4a e raised to the power 2t plus 4a e raised to the power 2t. So our third derivative will simply be 8a e raised to the power 2t plus 8, oh sorry, it's actually 8a e raised to the power 2t plus 8a e raised to the power 2t. This is our equation 3, this is our equation 2. I will be able to see that even. So this is our equation 2. So again, we are going to take equation 1 and equation 2. Our equation 1 and equation 2 in equation star, and remember our equation star is our inhomogeneous equation. So our inhomogeneous equation is 8at, so this is equation 3, e raised to the power 2t. What I'm doing is simply substituting it here. I'm substituting it here. So I'm substituting that equation 3 plus 8a e raised to the power 2t minus 4 into our first derivative from equation 1 here, this. We're going to have 2a t e raised to the power 2t plus a e raised to the power 2t. Now this will be equal to 24 e raised to the power 2t. So that's what we need to compute, and from here we can get the value of a. So simplifying this, we're going to have 8a t e raised to the power 2t plus 8a e raised to the power 2t minus 8a t e raised to the power 2t minus 4a e raised to the power 2t equals to 24 e raised to the power 2t. What do we notice? 8at e raised to the power 2t can go here with this, and 8a e raised to the power 2t here. This 8a e raised to the power 2t minus 4a e raised to the power 2t will give us 4a e raised to the power 2t. So meaning that we are going to have 8a e raised to the power 2t to be equal to 24 e raised to the power 2t. So this is going to cancel, and we are going to be left with 8a equals to 24. A should be equal to 24 divided by 8, and 2 can go here, 12, 2 can go here, 4, which will be 3, right? So our a is 3. So if our a is 3, then our particular solution, which is what we have been looking for all this while, is our a is 3 t e raised to the power 2t. So this is our particular solution. Now to solve the full solution, we have to combine. So for the full solution, let's call it general, will be y particular plus y complementary. This y complementary is this equation that we saw earlier here. This is also our y complementary. Is the solution to our homogeneous equation. So meaning that our y full solution, which is general, is our particular solution, which is 3t e raised to the power 2t plus c1 plus c2 e raised to the power 2t plus c3 e raised to the power negative 2t. This is the solution to our equation B. Our question C says that find the partial solution that satisfy the initial conditions. So the initial conditions given to us is y of 0 equal to 1. Remember that this implies that t is 0 and y is 0. Our second condition is y prime of 0 equal to 1. This implies that our t is 0 and our first derivative of our general solution is 1. And thirdly, our double prime of 0 is 0, which implies that our t is 0 and our double derivative, second derivative, is also 0. Since this is a third order differential equation, of course we are given 3 conditions, and we are going to come up with 3 equations and solve these equations simultaneously. So to do that, let's apply the first condition. So we're going to simply apply this first condition here. So yg, remember that we can just write this as y, but this was just to represent it as the general solution. We know that y here is 0 and t is 0, so 0 here equals to 0 here will give us 0 plus c1 plus 0 here will be c2 plus 0 here will be c3. This implies that c1 plus c2 plus c3 is equal to 0. This is our first equation. So we're going to use the second condition and the third condition to look for the other 2 simultaneous equations. So the second condition says the y prime of 0 is 1, which means t0 y prime is 1. So we're going to look for our first derivative of our general solution. So this first derivative will be, we'll look for the derivative here, and the derivative there is it's a product, so it will be 3 e raised to the power 2t constant. Differentiating t with respect to t will be 1 plus, then we're going to keep 3t constant. Differentiating e raised to the power 2t with respect to t, we are going to have 2 e raised to the power 2t, then plus differentiating c1 with respect to t will be 0, plus differentiating this with respect to t, we're going to have 2c2 e raised to the power 2t. Differentiating this with respect to t, we're going to have minus 2c3 e raised to the power minus 2t. We saw that from the condition this is 1, so 1 and our t is 0. This is where I'm getting the condition from. So inserting 0, we're going to have 3 here. Inserting 0 here, we're going to have 0 plus inserting 0 here, 2c2. Inserting 0 here, minus 2c3. So simplifying it, if we send 3 this way, we're going to have minus 2 should be equals to 2c2 minus 2c3. Dividing all through by minus, we're going to have our c3 minus c2 equals to 1. So this is our second equation. Then we're going to use the third condition to look for our last equation. So the third condition says, we have to look for the third derivative, right, of our homogeneous equation. So we have to look for the second derivative, not third derivative. So for us to get a second derivative, we are going to look for the derivative of the first derivative, right? So our main focus will be here. So this is where we are going to be looking for our second derivative. So in looking for our second derivative here, we are going to have looking for differentiating this with respect to t, we are going to have 6, right, because 2 comes down, 6 e raised to the power 2t. Differentiating this with respect to t, this again, notice that this is 6 is 60 e raised to the power 2t. So we are going to have plus 60, right, 60 as constant. Differentiating e raised to the power 2t, we are going to have 2 e raised to the power 2t. Then we are going to have plus 2, we are going to have 6 e raised to the power 2t constant, and then we differentiate t with respect to t, we are going to have 1. So we're done with this. Now this is 0. Here we look for our derivative. Our second derivative there will be 4c2 plus 4c2 e raised to the power 2t, and finally we look for our second derivative there, bring it down, differentiating negative 2t, we have negative, bringing it down becomes plus 4 c3 e raised to the power minus 2t. So this is our second derivative, and looking at this condition here, our second derivative is 0 and our t is also 0, so meaning that 0 should be equals to 6. This will be 0 because t is 0, then plus 6 plus 4c2 plus 4c3. So we already see here that 2 is common, right? So 0 should be equals to 3 plus 2c2 plus 2c3, and this will be minus 6 to be 2c2 plus 2c3. This is our third equation. Now from equation 2 and 3, we are going to get a value of c2 and c3, and from there I see we can even further simplify our equation 3. This will be minus 3, right, to be equals to c2 plus c3. Great. So this is our equation 3. Good. Now from equation 2 and equation 3, we are going to get a value of c2 and c3, and from these values we substitute in our original equation 1 here, and we're going to get the different solutions. Now what we need to do here is simply add these two equations. So if we say equation 2 plus equation 3, we're going to have equation 2 plus equation 3, we're going to have 1 minus 3 to be equals to c2 plus c3 plus c3 minus c2. So c2 is cancelling out, so negative 2 to be equals to c3. So our c3 is negative 1. If our c3 is negative 1, right, this our c3 is negative 1, we can substitute it in our equation 2 to get c2. So substituting this here in this equation here, we're going to have c3, which is negative 1, minus c2 to be equal to 1. So meaning that negative c2 should be equal to negative 2. So c2 should be equal to 2. So this is our c2, this is our c1. So c2 is 2, c1 is negative. Our c2 is 2 and our c3 is negative 1. So from here we can get our c1. So our c1 will be c2 is 2 minus c1, which will be so it's like this equal to 0. So our c1 will simply be negative 1. So those are the different values. So we just substitute it here, and that will be the final solution. So our final solution will be y equals to 3t e raised to the power 2t. So 3t e raised to the power 2t plus c1, right, plus c1 plus c1 plus c1 plus c2 e raised to the power our c2. What's our c1? We saw our c1 is negative 1, right, and our c2 is 2 plus 2 e raised to the power 2t minus our c3 is 1 e raised to the power minus 2t. So that's the final solution.